Every time you drink alcohol, even one single drink, a hidden switch flips inside your body. Not a metaphorical switch, a biochemical one. And once this switch turns on, your biology shifts into a mode that accelerates aging in ways that we can now measure in your mitochondria, your tissues, your brain, your liver, and even your stress response. This mechanism has nothing to do with calories, sugar content, liver toxicity, or the classic idea of a hangover. The real story is deeper and far more interesting. New evidence from metabolic and hydration research, including work published in Nature Metabolism, shows that alcohol triggers your body to produce its own internal fructose, even if you don't consume any fructose at all. And the moment that fructose appears, it activates an enzyme called Ketohexokinase, or KHK. KHK is one of the most aggressive enzymes in human metabolism. It rapidly uses ATP, your cell's energy currency, and it does this without a built-in braking system. When ATP drops, your cells shift from a youthful, efficient mode to a stressed, older state. I'm Dr. Amin Hedayat, a neuroscience-trained, triple board certified physician in pathology, dermatopathology, and clinical pathology, and I'm an assistant clinical professor of medicine. Most doctors rely on symptoms and conversations. My world is cells, slides, tissues, real biological evidence. People can tell you stories, but cells only tell the truth. And lately, I've been seeing something that concerns me. Signs of accelerated aging in tissues from people who are far too young to show them. Patterns that match exactly what this alcohol fructose ketohexokinase mechanism produces. Today I'm going to walk you through how alcohol flips this biochemical switch, why your body makes fructose internally, how ketohexokinase drains energy, how ATP loss affects aging, what this means for your liver, brain, gut, hormones, and metabolism, and why even light drinking can produce measurable biological change. My goal is not to shame anyone. My goal is clarity. Clarity creates power. And when people understand what's happening inside their biology, they make better choices without fear, guilt, or pressure. And if you find this breakdown helpful, feel free to tap like so more people can discover evidence instead of assumptions. But no pressure at all. I simply appreciate you being here. Let's begin with the discovery that changed everything. The story behind this aging mechanism didn't actually begin with alcohol. It began with dehydration research. Scientists studying blood osmolarity, which simply means how concentrated your blood is, noticed something interesting. When your blood becomes even slightly more concentrated from heat, exercise, stress, fasting, sweating, or not drinking enough water, the body interprets that as a survival stress. In that moment, your body activates a pathway that takes glucose, your normal blood sugar, and converts it into fructose internally. This is not dietary fructose. This is endogenous fructose made inside your own cells. Why would the body do this? Because fructose triggers a survival response. In humans and in animals, fructose is associated with storing fat, slowing metabolism, conserving energy, reducing repair, and preparing for scarcity. These are well-established physiological responses. This was incredibly useful for early humans who needed to survive droughts, winters, and long migrations. But here's where the modern life complicates things. Alcohol raises blood osmolarity in a similar way to dehydration. So your body responds to alcohol as if you're entering a period of stress or scarcity. It activates the pathway. It creates internal fructose, and that fructose activates KHK. This pathway has been measured in human tissue, lab models, and clinical metabolic studies. And once KHK activates, your cells enter the next phase of the cascade, the one most people don't understand, which is the ATP depletion. Let's make this very simple. Your cells run on ATP. ATP is the energy that powers everything. Your brain, your muscles, liver, metabolism, hormonal signaling, detoxification, mood, recovery, immune system, you name it. Now imagine an enzyme that uses ATP rapidly without a braking system. That enzyme is Ketohexokinase, also known as KHK. KHK takes fructose, including the fructose your body makes from alcohol, and rapidly phosphorylates it. That biochemical reaction consumes ATP extraordinarily fast. Most enzymes slow down when energy drops. KHK does not. It keeps going until it runs out of substrate. And when ATP drops, your cells shift into a different biological state. This part is important. A youthful cell behaves like this: high energy, efficient, low inflammation, strong mitochondria, fast repair, stable, flexible metabolism. A low energy cell behaves slower, more inflamed, reduced repair, more oxidative stress, less resilient. This shift, youth mode to defense mode, is one of the earliest measurable signs of biological aging. People feel it even after light drinking. I slept, but I woke up tired. My brain feels a little dull today. My workout feels harder than it should. I'm more irritable for no reason. My digestion feels heavier. These are metabolic signals. Microscopically, you can track this difference. Mitochondria appear swollen. Cells look stressed. Inflammatory cells begin to rise. Early fat droplets appear in liver tissue. Endothelial cells, which are the blood vessel lining, look strained. These changes appear long before blood tests show abnormalities. And once mitochondria feel the stress, they begin to enter a pattern that drives aging across the entire body. And that's exactly where we go next. And this is the part that people send to their family and friends because it finally explains what they've been feeling. Now, let's talk about what happens the moment ATP drops, because this is where aging actually begins, inside every one of your cells. You have tiny structures called mitochondria. Mitochondria are not just energy factories. They are the biological guardians of youth. They determine how much energy you have, how efficiently you repair, how quickly you recover, how stable your mood is, how sharp your brain feels, how resilient your metabolism is, and how young or old your cells tend to behave. A youthful mitochondrion is structured, efficient, and clean. It produces ATP with low waste. It adapts quickly to stress. It supports high cellular repair. And when KHK activates and ATP drops, mitochondria shift into emergency mode. Emergency mode looks like this. They burn fuel less efficiently. They leak more reactive oxygen species. They produce less ATP. They become swollen or fragmented. They send distress signals to the rest of the cells. People feel this immediately. My stamina isn't the same. My workouts feel harder. I hit a wall earlier in the day. My mood dips faster. I don't recover the way I used to do. And here's the thing. These feelings are not in your head. They are mitochondrial responses. Under the microscope, you see swollen mitochondria, reduced cristae definition, disorganized internal structure, early oxidative stress signatures. These are signs of accelerated mitochondrial aging. And when mitochondria are stressed, they send a message to the entire body. We don't have enough energy. Slow everything down. And that message activates the next stage of aging, inflammation. Inflammation is not always loud. It's not always painful. It's not always noticeable. The type of inflammation that accelerates aging is actually silent. This is what researchers call low-grade systemic inflammation, and it's one of the strongest predictors of accelerated aging, chronic disease, and metabolic decline. Here's how alcohol triggers it. When mitochondria are stressed, they leak small amounts of reactive oxygen species. Your immune system interprets that leak as sign of danger, and it activates inflammatory pathways. A major one is NF-kappa B, often called the master switch of inflammation. Once this switch flips on, it increases the production of inflammatory molecules like IL-6, TNF-alpha, and CRP, and you can measure that in the blood. These molecules travel everywhere in your body and influence metabolism, blood sugar stability, immune balance, hormone signaling, liver function, brain chemistry, gut barrier strength, vascular flexibility. And you feel this inflammation as a lower mood, brain fog, morning heaviness, slower recovery, more cravings, less emotional bandwidth, tired but wired, a sense that my body feels older this week. Microscopically, this is demonstrated by showing that there is subtle collagen softening, micro tears in blood vessel lining, small droplets forming in liver cells, mild inflammatory cell clustering, early fibrosis shadows, changes in the texture of tissues that signal stress. These are the fingerprints of inflammaging. And the organ that absorbs the greatest burden is the liver. And that's our next stop. Most people think liver problems show up on lab tests, but that's not how liver aging actually starts. Your liver is one of the most metabolically active organs in your body. It is responsible for detoxification, hormone processing, glucose regulation, fat metabolism, inflammation control, and hundreds of biochemical reactions. So when the alcohol fructose KHK pathway activates, guess where most of the internal fructose gets processed? The liver. Fructose metabolism in the liver can increase de novo lipogenesis, meaning your liver starts producing fat internally. This can happen long before you ever see elevated ALT, elevated AST, which are liver enzymes. The earliest clues are microscopic. Under the microscope, you might see micro droplets of fat inside liver cells, early mitochondrial swelling, inflammatory cells around tiny fat pockets, subtle fibrotic streaks, slight distortion in the architecture around the central vein. These are the earliest fingerprints of liver aging. You may feel this as sluggish mornings, more cravings, heavier digestion, less metabolic flexibility, mood fluctuations, fatigue after meals. But the most important connection is this: when the liver begins to struggle, even slightly, the brain becomes vulnerable, because the liver communicates constantly with your brain through hormones, inflammatory signals, and metabolic feedback loops. Which brings us to the most sensitive and most important part of this entire cascade: brain aging. If there's one organ that cannot afford an energy shortage, is your brain. Your brain is the most energy-hungry organ in your body. It uses around 20% of your total ATP, even when you're doing nothing. So when KHK drains your ATP, your brain notices instantly. Here's what happens. Neurons fire less efficiently. Communication between brain cells slows. Neurotransmitters cycle more slowly. Signals feel heavier. People describe this as, my brain isn't as sharp today. My thoughts feel slow. I can't lock in like I usually do. I feel a little emotionally raw. My motivation is off. This is not psychological. This is biochemical. And then comes the second hit: inflammation inside the brain. Inflammatory molecules from the bloodstream can cross the blood-brain barrier and activate microglia, the brain's immune cells. Microglia are supposed to protect you. But when they stay activated, they begin causing low-level neuroinflammation. This is one of the earliest steps in cognitive aging, identified in research published in Trends in Neuroscience in 2022. Under the microscope, the early clues of neuroinflammation looks like microglial clustering, swollen supporting cells called astrocytes, subtle structural disorganization, early oxidative markers in neural tissue. These are changes that appear years, sometimes decades before clinical symptoms. And then we reach the third hit: dopamine. Dopamine is the chemical that controls motivation. It controls drive, focus, initiative, and emotional resilience. But dopamine neurons are extremely energy dependent. When ATP drops, dopamine signaling weakens. People feel this as reduced motivation, lack of follow-through, procrastination, emotional fatigue, reduced enthusiasm. This isn't just life. This is a metabolic consequence. And when dopamine drops, your entire stress system shifts. That's where we go next. Right underneath your conscious awareness, your autonomic nervous system controls your heart rate, your digestion, your immune tone, your emotional stability, stress resilience, your recovery. Your autonomic system has two modes: sympathetic and parasympathetic. Sympathetic is alert, active, stressed. Parasympathetic is calm, restorative, healing. A youthful nervous system shifts between these modes gracefully. But when ATP drops and inflammation rises. Your body drifts into a chronic low sympathetic state. It's not panic. It's not anxiety. Just tension. A subtle tightening. You feel it as lighter sleep, reduced heart rate variability, a shorter fuse, more emotional friction, feeling off, but not sure why, slower recovery after stress, difficulty relaxing, even when tired. This is autonomic aging, and it happens far earlier than most people realize. Under the microscope and in physiological studies, this correlates with early endothelial stress, microvascular rigidity, hormonal imbalances, reduced vagal tone, increased inflammatory signaling. This is where aging becomes a network. Not one organ, not one symptom, but a system-wide shift. And this brings us to the next stage, cellular repair breakdown, which begins the deeper aging cascade. Everything we've talked about so far, ATP loss, mitochondrial strain, inflammation, liver changes, brain fog, stress system rigidity, all leads to one critical consequence. Your repair systems begin to slow down. And repair is the foundation of youth. Every day, your cells are damaged by metabolism, stress, chemicals, oxidation, normal life. When you're young, biologically young, your body repairs this microscopic damage effortlessly. But repair requires three things: energy, low inflammation, and healthy mitochondria. And after alcohol flips the fructose KHK pathway, you have less energy, more inflammation, stressed mitochondria. So the body makes a decision. We don't have the resources to repair everything. Let's cut back. This is the moment aging accelerates. Inside the cell, the first system to slow is autophagy, your cellular cleanup program. Autophagy removes damaged mitochondria, misfolded proteins, oxidized lipids, cellular debris. But when ATP drops, autophagy becomes sluggish. Under the microscope, this looks like clumped proteins, swollen organelles, built up waste, dull, crowded cytoplasm. These are early signs of cellular aging. The next thing that slows is DNA repair. Your DNA experiences small breaks every day. Normally, repair enzymes fix them almost instantly. But when energy is low, these enzymes become inconsistent. You don't get catastrophic mutations. You get subtle errors, changes in gene expression, tiny shifts in cellular timing. This is called epigenetic drift. It is one of the strongest predictors of biological aging. And then comes a deeper shift, one that I see often: cellular senescence. Senescent cells are cells that have stopped dividing but refuse to die. They sit in your tissues like zombie cells, releasing inflammatory chemicals that speed up aging in every cell around them. You see senescent pattern in older tissue, but increasingly in tissue from people who are biologically far too young. The common denominator is typically inflammation, oxidative stress, and repeated ATP depletion. This is exactly the environment the alcohol KHK pathway creates. And once repair slows, aging spreads to the system that depends on microscopic blood flow the most: your blood vessels. If you want a real-time snapshot of your biological age, don't look at your wrinkles. Look at your blood vessels. Your vascular system is how your brain gets oxygen, how your muscles perform, how your heart regulates pressure, how your gut absorbs nutrients, how your immune system travels, how your hormones circulate. When your blood vessels age, everything ages. And the alcohol fructose KHK pathway affects blood vessels in three major ways. 1. Endothelial stress. The endothelium is the thin lining inside every blood vessel. It is highly sensitive to inflammation and ATP loss. When ATP drops, endothelial cells stiffen, produce less nitric oxide, repair more slowly, become more inflamed, become less responsive. Low nitric oxide means higher blood pressure, reduced exercise performance, slower recovery, reduced sexual function, lower brain perfusion. 2. Capillary fragility. The smallest blood vessels, called capillaries, are the most energy dependent. Tiny changes in ATP lead to tiny changes in microcirculation. Under the microscope, microvascular aging looks like narrowed capillaries, early fibrotic changes, endothelial cell irregularities, reduced capillary density. These changes impair your skin, your muscles, your brain, gut, your recovery, your metabolic flexibility. Number 3 is blood-brain barrier vulnerability. Chronic inflammation and oxidative stress can weaken the blood-brain barrier, the shield that protects the brain. It becomes porous. Inflammatory molecules can enter brain tissue. This accelerates cognitive aging, mood instability, stress reactivity, neuroinflammation. And this is the earliest stage of vascular cognitive decline, years before symptoms become obvious. And all of this connects to the next organ in the cascade, your gut. The gut is not just a digestion system. It is a multi-organ network that influences nearly every aspect of your biology: immunity, hormones, inflammation, metabolism, even your mood and motivation. And the gut is extremely sensitive to ATP levels, inflammation, oxidative stress, alcohol, and fructose metabolism. Here's what happens when the alcohol KHK pathway activates. The microbiome shifts, healthy bacteria decline, inflammatory bacteria expand. Butyrate, which is a metabolite that protects your gut and reduces inflammation, decreases. This microbiome shift affects mood, cravings, metabolism, inflammation, immune balance, serotonin levels. The gut barrier weakens. Your gut lining is only one cell thick. These cells rely heavily on ATP. When ATP drops, the tight junctions between cells weaken. Tiny gaps open. This allows bacterial fragments, especially lipopolysaccharides, to leak into your bloodstream. This is called metabolic endotoxemia, and it is one of the most powerful drivers of systemic inflammation and accelerated aging. People feel gut aging as bloating, food sensitivities, afternoon crashes, brain fog, increased irritability, difficulty recovering from stress, immune overactivation, because 70% of your immune system lives in your gut. A weakened barrier forces your immune system into a constant state of alert. This doesn't feel like a fever. It feels like aging. And once the gut ages, it accelerates aging in every organ it communicates with, including the brain and liver. This is where the aging process stops being a list of symptoms and becomes a cascade. Now, let's put this together. Aging isn't random. It doesn't happen one organ at a time. It begins with a few signals, and those signals spread. Alcohol raises blood concentration. Raised blood concentration creates internal fructose. Internal fructose activates KHK. KHK depletes ATP. Low ATP stresses mitochondria. Mitochondria trigger inflammation. Inflammation impairs liver, brain, gut, and vessels. Impaired system lead to slow repair. Slow repair increases cellular aging. Cellular aging leads to vascular and immune aging, which accelerates whole body aging. This is the mechanism I see reflected in tissue every day. And here's the empowering part. This entire cascade is reversible, not in years, in weeks, maybe months. When you stop activating the alcohol fructose KHK pathway, your biology doesn't drift, it rebounds. Here's the actual timeline seen in clinical research, metabolic studies, and cellular physiology. Usually within 24 to 72 hours, ATP levels rise. Mitochondrial stress decreases. Inflammation begins to fall. Energy improves. After 1 week, you typically see brain fog starting to lift. Sleep deepens. Heart rate variability improves. Cravings tend to decrease. Mood tends to become more steady. And after 2 to 4 weeks, liver fat begins to decline. Gut barrier strengthens. Dopamine signaling improves. You wake up more clear. Stress tolerance increases. After 2 to 3 months, autophagy ramps back up. Vascular function improves. Skin looks healthier. Metabolism stabilizes. And month 3 and beyond, you see measurable reductions in biological age, improved epigenetic markers, healthier hormone rhythms, higher detox capacity, stronger mitochondrial networks. Your biology wants to heal. It's built to heal. The moment the stress signals drop, the repair systems turn back on. And this brings us to one of the most common questions I get. What exactly gets younger? Here's what improves when the alcohol KHK pathway is turned off. Regarding inflammation age, CRP drops, IL-6 and TNF alpha drops. Regarding metabolic age, you see insulin sensitivity improves. Glucose variability decreases. Liver fat reduces. Regarding mitochondrial age, you see ATP output increases. Reactive oxygen species decreases. Mitochondrial networks become more youthful. Regarding hormonal age, you see cortisol rhythm normalizes. Thyroid conversion improves. Sex hormone signaling balances. Regarding vascular age, you see nitric oxide rises, arterial stiffness decreases, endothelial function improves. Regarding gut age, you see microbiome diversity increases, butyrate rises, gut barrier strengthens. And regarding brain age, you see dopamine tone improves, microglial activation decreases, motivation and clarity improves. Regarding epigenetic age, you see DNA methylation patterns shift toward youth. Cellular stress signals decline. This is what biological age really means. And you can influence it more than most people have ever been told. Here's a truth I want you to walk away with. Aging is not just a number, it's a pattern. A pattern your body responds to every single day. And alcohol, through this newly understood fructose KHK pathway, sends one of the strongest aging signals we know. But the most important part is this: you're not fragile. Your body is extraordinarily adaptable. And the moment you stop sending an aging signal, you automatically start sending a healing signal. You don't need perfection, guilt, or quit forever. You only need clarity, the clarity that comes from understanding your own biology. Your mitochondria listens to you. Your liver listens to you. Your brain, gut, cells, they all listen to you. And they always prefer youth, repair, and resilience. If this breakdown helped you understand your biology more clearly, please feel free to share it with someone you care about. Not to scare them, but to empower them with the science you were never taught in school. And if you want more medically rigorous, compassionate, high-level content like this, you're always welcome here. You can tap subscribe if you'd like to be part of this community. No pressure. But it helps me continue making videos like this. Thank you for spending your time with me. And remember, youthfulness is not an age. It's a signal. Send the right one. I'm Dr. Amin Hedayat, and I'll see you in the next video.